AI large language models are becoming more and more capable. It's my belief that human-level intelligence is not a ceiling and that one day they will surpass the general intelligence levels of your average basement developer. That being said, smart contract development is so niche and security critical that their use isn't well suited to the careful planning, design, and testing required for blockchain developers. Yeah. In this video, we're going to be using OpenAI's Playground with the new reasoning model to build custom prompts and context windows to push the boundaries of what is possible using ChatGPT. The goal? To create a decentralized application hosted on the Stellar blockchain. For this challenge, I wanted to create something functional and semi-useful that would showcase what AI and Web3 can do. A SAFT is a simple agreement for future tokens, a widely adopted legal contract used by VCs invested in Web3 startups. This is something that could and perhaps should be on-chain. The idea is that a pre-product startup raises funds to bootstrap their project on the promise that they'll deliver a governance tokens at a later date to the VCs that invested. In practice, it looks like this. You have a token allocation, the percentage of the total supply going to the VC, then a vesting schedule set out over a number of years. In this example, 25% is released during a token generation event or launch, and then a further 25% every 12 months until the VC receives their full allocation. All fairly straightforward, but can we put this into a smart contract so that the teams can raise directly on chain? The idea would be that a founder sends or mints tokens to the contract, perhaps even directly within the contract, and then VCs can send USDC to receive a time-locked allocation. Time frame for building, testing, and deploying this? A week, maybe a month? Let's see if AI can do it in hours rather than days. So we're going to be putting this simple agreement for future tokens into a smart contract. Let's go ahead to platform.openai.com and let's choose a model. I'm going to be using O3 Pro here. This does tend to be a little bit pricey. It's one of the latest reasoning models, so as the context window builds, it's going to get a little bit pricey. I then want to give it a system message. Just tells the AI model what to do and what's expected of it. I used ChatGPT to generate this and gave it some kind of initial ideas and a starting point, and then got it to write a full system prompt. All these prompts are open source and they're linked to in the description. Then I want to give it some more information in the context window. What I want to do is provide a time lock contract. I found this in the Soroban examples GitHub repository, and I think it's going to be really useful because it demonstrates how to use time locks within a Soroban smart contract. So we're going to pass that information across to the AI large language model to give it a head start. I want you to create a Soroban smart contract for a SAFT simple agreement for future tokens. The contract should allow a founder to deposit tokens and set terms. A VC or investor should then be able to deposit USDC to the contract and get a time-locked allocation. All terms should include a hard-coded vesting schedule where 25% of tokens are unlocked over each period, and the founder should be able to set how long that period is. If the founder sets a period of 1 year, then 25% are unlocked after the TGE, or during the TGE, then 25% 1 year later, 25% 2 years later, and 25% 3 years later. The founder should be able to call a function to unlock the first round and initialize the TGE. The VC should then be able to call a function to claim the unlocked tokens. Here's an example of the time lock contract from Soroban. I'm going to paste that contract we found earlier in. Just going to tweak this a little bit and then hit go. This could take a little time to complete. The reasoning models can take 1 to 5 minutes to kind of execute a query like this, which is quite complex. Then hopefully it's going to spit out a working Soroban smart contract. And here we go. We've got a little bit of information about the flow, and then we've got the contract here. That's okay, but what I failed to mention in the prompt is that I want this to work with as like a multi-user contract. So multiple founders can go in and set up their raises on a single contract, and then a VC can come in and see the available raises and deposit funds to one they want to allocate to. So at the moment it's set up for just one founder to kind of set up their individual token sale, whereas I want it to be a multiple user for like a fundraising platform. So let's just tweak the prompt a little bit and ask it to change that into a multi-user contract. Once that's gone through, we can copy this. Let's just check it compiles. I'm going to copy this into the Soroban Playground and let's just test your smart contract. There aren't actually any unit tests in this yet, but it will just show us that it's running okay, it compiles fine. So all looks good. So far, so good. So now I want to move this across to the Scaffold Stellar client. So I'm going to set up a new repository. You can do this using cargo install Stellar Scaffold Cli and then Stellar Scaffold init my project. That's going to give us a kind of a working React front end and smart contracts in the background, which are all connected up. We can create the bindings for that automatically, and we can use that as the kind of the base to build this decentralized application. So far we've got the large language model to create the smart contract. Now I want to create some unit tests just to make sure it works okay. This is where things got a little bit fun. I had to reiterate a little bit where it wasn't compiling the unit tests, and then there were unit tests failing, and I had to keep copying the errors messages and then passing that through back to the large language model to kind of get it to fix the errors, either within the contract or the test suite. It's kind of a similar process to what you do as a developer, but you're trusting an AI to do that for you rather than actually kind of understanding and going through the contract line by line. So one thing I note is that if you're going to do this for a hackathon or testnet, this is fine, but if you're going to put this into production and it's going to be holding real users' funds, a human really needs to understand every line of that contract. You need to know the nuances of what's going on and kind of get your head around the complexities of that contract and how funds are moving around to fully understand the security implications. If you're going to be responsible for your users' funds, then there's a lot of responsibility there, and you really need to you can't trust all of that into AI at the moment. Eventually we got all the unit tests to pass, and it's quite impressive already that ChatGPT or the latest large language models at least, can create these very complex decentralized systems within smart contracts, and they're executing and they're working and they're functional. I'd expect if I was going to write this myself with kind of a spec and then a smart contract and a unit test on top of that, probably going to look at a week's work, and it done this in less than an hour. Then we switched to the front end, and we were using a new system prompt here. This prompt is designed for a front-end developer. It mentions scaffold Stellar, so it's given some information about how that project is put together with React and Vite. And then we're going to pass some information like the key files across in the context window. We're also going to deploy the smart contract to the testnet using a Stellar client, and then copy that contract ID into our environmental variables. We then fire up a dev server and get hit by a bunch of errors. This is where the real challenge of this project came in. I spent maybe a couple of hours just kind of going back and forth with ChatGPT, losing the will with OpenAI and large language models and vibe coding in general, because I was constantly kind of pulling the errors out, giving them to OpenAI, then they're fixing that error and it's coming up with something new. In some ways, it may have been better to use something like Claude Code or Cursor, which kind of has full access to the repository that you're working with. So it could have picked out different files and kind of better understanding of the overall kind of project, rather than kind of try and curate the amount of information I'm passing in manually. I hit a bunch of issues with the binding itself and interacting with the smart contract. But eventually, after a lot of back and forth, we ended up with this little decentralized application. And the beauty of this is that it was completely created by AI. I kind of passed information on errors to and from and done like a little bit of kind of tweaking manually where something was obvious, but all the code here is either kind of from that original boilerplate or it's been generated by AI. All I did was copy and paste things and follow instructions by the large language models on how to fix certain errors which were popping up. Would I deploy this as it is to mainnet or trust it with real users' funds? Absolutely not. It would need to go through stringent security tests, and I think there's still a benefit to using AI in a more modular way to kind of create individual functions so that you get a better understanding of the contract as a whole, rather than having it do everything for you and expecting it to do the complete contract and the kind of connections to the front end as well. It's definitely, however, proved itself that it is very capable, and it's only become more and more useful over time. If you're going to be using it as a tool for a developer, it can increase your productivity and enable you to do things that you might not have been able to do on yourself, especially within a constricted time frame. Even a year ago, because Soroban was so new and the large language models weren't as advanced, it would have had absolutely no chance of completing this task. But it's actually impressed me with how far we've come in such a small amount of time. There's more training data out there now, and the models are advancing at a rapid pace. Then they're only going to get better and better. I hope you've enjoyed this video. Please bear in mind that the code here is for demonstration purposes only, and developers should take all necessary precautions when handling funds within a smart contract. If you're interested in building on Stellar, then there's a full tutorial with the prompts I use and resources in the description. Thank you for watching.